Okay, so Miss Sanders worked with you guys on multiplying polynomials, so now we're going to talk about multiplying special cases. It's still going to be foiling, still going to be distributing, stuff like that, but it's just going to be a special case that you're going to see within certain polynomials. So to kind of lead off the discussion, I just give you a table that gives you the values for x and y and different expressions. So now we're going to complete the table. So if my x is 7 and my y is 4, I could do 7 minus 4 times 7 plus 4. Well, 7 minus 4 is 3. 7 plus 4 is 11. So 3 times 11 gives me 33. So another way to think about this, x squared, well, that's 7 times 7 is 49. Y squared, that is 16. Well, what is x squared minus y squared? Again, that's 33. So kind of the same thing. Now let's change the x and y. So the x is 6, the y is 2. So I would do 6 minus 2 times 6 plus 2. Well, that's 4 times 8, which is 32. 6 squared is 36. Y squared, which is 2 squared, is 4. So I could do 36 minus 4, which would give me 32. So again, we'll switch x and y. 3 minus 9. 3 plus 9. Well, that's 12 times negative 6, which is negative 72. So I could do x squared, which is 9. Y squared, which is 81. 9 minus 81 gives me negative 72. So hopefully you're kind of sitting there and saying, well, the pattern here is that xy, or x minus y times x plus y is the same as x squared minus y squared. So now let's substitute 7p and 4q in for x and y. And let's see if the pattern still is going to be true. So 7p minus 4q and 7p plus 4q. Well, last class you guys foiled, so we're going to foil it. So first times first would give me 7p times 7p, which is 49p squared. We do the outside, 7p times 4q, which is 28pq. Negative 4q times 7p would be negative 28pq. And then my last ones would be negative 4q times positive 4q, which would be negative 16q squared. But if you think about this, I'm going to combine the pq's because they have the same variables with the same exponents. Well, those are going to cancel, so my answer is going to be 49p squared minus 16q squared. Well, our pattern was saying that 7p squared minus 4q squared was going to be my answer. 7p squared is 49p squared, and 4q squared is 16q squared. So the pattern still holds true even if it's not a number. So even if we have variables with a different leading coefficient in there, it's going to have the same pattern. So that kind of leads into our special cases. So why is a plus b squared considered a special case when multiplying polynomials? Well, if you think about a plus b squared, okay, what that really means is that means a plus b times a plus b. Okay, and it's very similar, like think about this, guys. If I had 4 squared, well, that means 4 times 4. So I'm just taking my base, and I multiply by itself however many times the exponent tells me to. Well then, if I do a plus b squared, that turns into a FOIL pattern. So I would get a squared plus ab plus ab plus b squared. Well, the pattern is that you take a squared plus b squared, and then you multiply a and b and you double it, and that's going to be your middle term. So really what I want you to know is the big thing is that 3x minus 4 squared, well, that means 3x minus 4 times 3x minus 4. So then I could FOIL it. So I would get 9x squared minus 12x minus 12x plus 16. So it's going to be 9x squared minus 24x plus 16. And just kind of going back to the pattern, like why is it a special pattern? Well, 3x times 3x would give me 9x squared. That's my first term. That makes sense. Now if I take a times b, which is 3x times 4, which is negative 12x, and then I double it, that'll be the middle term. So negative 12x times 2 would give me negative 24x, which is the middle. And then I square the last number, which is negative 4. Negative 4 times negative 4 is a positive 16, and that gives me the last number. So there is a pattern. However, as long as you know that you just need to FOIL it, then you should be fine. So 5x minus 3 squared actually means 5x minus 3 times 5x minus 3. So go ahead and try that by yourself. Pause the video, see if you can figure this one out, and just FOIL it. So 5x times 5x gives me 25x squared. 5x times negative 3 is negative 15x. So I did those two first. Now I'm going to do the inside, which would be negative 15x as well. And then the last, which would be a positive 9. So my answer should have been 25x squared minus 30x plus 9 because I can combine my two negative 15x's. Alright, so then it leads into one of our last special patterns. It says, what is the product of a plus b times a minus b? Well, if I FOIL, that would be a squared minus ab plus ab minus b squared. If we notice, the ab's are going to cancel, so I'm going to have a squared minus b squared. So really what it is, it's just the first term squared minus the second term squared. So if I FOIL this, well, 5x times 5x is 25x squared. 5x times negative 7 is negative 35x. 7 times 5x is negative 35x. And then our last one is positive 35x. And then our last one would be 7 times negative 7, which would be negative 49. Well, again, what we just did, the middle is going to cancel. So then I'm going to have 25x squared minus 49 as my final answer. So the pattern is that the first term squared minus the second term squared is going to give you your answer. So go ahead and try A. If you wanted to do the shortcut, pause it. And if you think about it, you could just do 4x squared minus 16. That should be my answer. But if we FOIL, right, we'll get 4x squared plus 8x minus 8x minus 16. Well, those are going to cancel, so then I would get 4x squared minus 16. And again, these are just called special patterns because notice the A and the B are the same. However, if I put a plus or a minus sign in between them, it changes the outcome. So if one's a positive, one's a negative, right, the middle term's going to cancel. If they're both the same, then it's going to be AB times 2 to give you the middle term. So that's really our special cases, and that's what we want you to focus on. Okay? If you guys have any questions over this, make sure you reach out to Ms. Sanders or myself. That is really all it is. Instead of assigning homework over this, what we're going to do is we're going to give you a worksheet overview from the first lesson all the way to now. So make sure you get that done. If you have any questions, again, reach out. We'd be more than happy to help.